Hello, good morning everyone. Um, Today we'll see different type of RDDs that are available in Spark. So RDD is the acronym for Resilient Distributed Dataset. Okay, these are the workhorses for any Spark system. So whatever you deal with the Spark will be dealt in the form of RDD. Okay. So we'll see various ways of creating an RDD and various ways of transforming the RDDs and various actions that are performed in the RDDs in the coming sections. Okay. As a user, one can consider RDD as a handle for the collection of individual data partitions. Okay. RDD is nothing but it contains of completely the data partitions. Okay, which are either result of some computation or uh, the RDD creation. It can be in any of thing or transformation. Okay. Uh, the RDDs can be need not be residing on a single machine, but if you consider a cluster, they can be spread across multiple nodes. Okay, the additions, uh, the partitions can be spread across a multiple nodes. So using an RDD as a handle, one can access all the partitions and perform computations and transformations that contain the data. So sitting on the master, we can easily control or we can easily access all the partitions that are spread across the cluster, and we can perform many computations and transformations on the RDD data. Okay. The best part of RDD is whenever an RDD is lost, okay, the system can able to reconstruct the data of the lost partitions just by using the linear information. Okay, so when you're performing any operation or when you're running any job on the cluster where the complete data is dealt in the form of RDDs, and if by chance if any partition is lost, okay, the system will be capable of regenerating or uh, regenerating the RDD again and performing the work. Okay, as a user, we need not worry about the data loss or redundancy or security. Everything will be taken care by the framework and system, so that and all the lost partitions can be recovered immediately. Basically, these RDDs are a logical partitions, okay, not a physical partitions initial. And the best beauty of Spark is like having the lazy evaluation till it sees the action, it won't perform anything. Okay, uh, like lineage refers to the sequence of transformations that are used to produce the current RDD. That's what I said. The actual computation will start only once we see an action. Till then, everything is a logical operation itself. Okay. Also, if any partition is lost, the Spark is able to recover the lost partitions and can able to complete the job without in a seamless manner. Okay. Internally, RDD is characterized by mainly five properties. One is it's a list of partitions, a function for computing each split, the list of dependencies, and optionally a partitioner of key value RDDs. Okay, if it's a hash partition RDD. Okay, optionally preferred location to compute each split. Everything. So these are the five properties of the RDD. Okay, and if you see the overview, RDD is available in Spark that derive directly or indirectly from the class RDD. If you see, the RDD class is the main abstract class. That's a if you see, this is the super class or the parental class for all the RDDs. Okay, and from here only we'll get all the descendants of the subclasses. Okay, the RDD, the base class abstraction of Spark. Okay, that's what I want to say. It's a base class and abstract class that is available for deriving for all the other subclasses. This class comes with some set of methods that can perform some operations on the data associated with the partitions. Okay, so for example, the basic set of methods that are available for an RDD is like map, filter, persist, these type of basic things. Okay, but and later on, depending upon the data which you want to deal, there are some subclasses where we get different types of RDDs we want to do. We'll have a look at it later. Okay, the class RDD is the abstract class. Whenever one uses an RDD, it is actually using the concreted like implementation of RDD. Okay, I mean, like we know the actually the meaning of abstraction. Like if any class defined as an abstract will have some methods which are not implemented in the abstract class. So in order to have their own concrete implementation, when we are trying to use that RDD, we can have our own implementations according to our requirement so that the job can be done. Okay. Um, so these implementations have to override some of the core functions make to make the RDD to behave as expected. Okay. One of the reasons why Spark has become much popular these days in processing the big data is it will not impose any restrictions regarding what data is stored within the RDD partitions. So that's a clear abstraction. It really don't care about what data is getting stored in the partitions. Okay, the RDD API already contains many useful operations. Okay, because the creators of Spark had to keep the core API of RDD common enough to handle the arbitrary data types, many convenient functions that are missing. So the basic RDD API considers each data item as a single value. However, sometimes, I mean, uh, this is like starting of the origin. Okay, initially, the developers thought that each data is a single item. Okay, but in the later stages, when you want to deal with the key value pairs, then this base class RDD is extended to the pair RDD functions, so that which allows the user to work on key value pairs. Okay, for example, reduce by key, aggregating by key. These are all the different functions that will be acted on the top of pair RDDs. So we'll have some examples in the later section of the class. Okay, this is one extension of the basic RDD. Okay, currently there are like 4 extensions that are available to an RDD API, and let us see what are all that. Okay, the first is like double RDDs. Okay, this extension contains many useful methods for aggregating the numerical values. Okay, they become available if the data items of an RDD are implicitly convertible to Scala data type double. Okay, if the data type is double and there are multiple what do you call functions that can be applied on that value on these numerical values. Okay, for example, if you see in this for example, if you see the double RDD functions, these are all the methods that are available where we can perform on the data. For example, computing the mean, okay, approximate mean, statistics, standard deviation, some approximation, variance. Okay, so these are all the functions that are available in the double RDD functions. In a similar way, if you see the base RDDs, I mean the parental class RDD, we have some methods called performing the aggregation, cache, Cartesian, coalescing. It means like combining multiple units into a single point. Okay, collect, count, context, count by value. These are all the map, flat map. So these are all the different operations that are available on the normal class RDDs. In addition to it, depending upon the extension, for example, if it's a double RDD functions, there are some functions which can be uh, performed on that double type of data type of values. Okay, if you see here, the next type of RDD is paid RDD functions. Okay, the methods defined in this interface extension become available when the data items has a two component tuple type of structure. Okay, if you have a data that is having key value pair of structure, Spark will interpret that first tuple item as a key and the second item as a value. So by taking the key value pairs, we can perform multiple operations on the top of the data. If you see this, for example, pair RDD functions, we can understand like what are all the operations, the transformations and actions that we can perform, like grouping them, combining by key and collecting as a map. Okay, and we can see the count, the number of keys are there, all the flat map values, fold by key. I mean, these are the different operations. We can perform left outer join with the one RDD with another RDD, right outer join, collecting the keys. So these are all the different operations that are explicitly related to the pair RDD functions, which are not base RDD. If you want to see the next type of RDDs, for example, ordered RDD functions, methods defined in this interface extension become available if the data items are two component tuples where the key is implicitly sortable. Okay, this is a super class of the pair RDD functions. Okay, if you have multiple types of tuples, okay, and we can easily deal with two tuples where the keys are implicitly sortable. Okay, even we can have a look at what are the different operations that can be performed on the uh, what do you say, ordered RDD functions. The next type of RDD function is sequence RDD function, where uh, this allows you to uh, create Hadoop type of sequences from RDDs. Like if you want to deal in a binary type of data, then we must be able to use this sequence file RDD functions. Okay, the data items must be two component tuple values as required by the file. So in this way, we can handle multiple sequence RDD functions in addition to the existing things. Okay, and we should be able to convert the components into a writable type of data types. Okay, we in addition to the primitive data types. So this is the hierarchy. Okay, um, the for the base is like RDD, and below that we can have pair RDDs, double RDDs, sequence RDDs, and order RDDs, and many things like that. Okay,